I will discuss about UV visible spectroscopy. UV visible spectroscopy. This is also known as electronic spectroscopy. Electronic spectroscopy. Before the discussion about UV visible spectroscopy, we know about the Beer-Lambert law. So at first we know the Beer-Lambert law. Beer-Lambert's law. Beer-Lambert's law is an absorption law. In this law, the law is when a beam of monochromatic light is passed through when a beam of monochromatic light is passed through a pure homogeneous of a light absorbing materials, the decrease in the intensity of light with the thickness of solution is directly proportional to the concentration of solution is directly proportional to the concentration of the solution to the intensity of light. So this is the statement of Beer-Lambert's law. So what? When a beam of monochromatic light is passed through a pure homogeneous solution of a light absorbing materials, the decrease in intensity of the light with the thickness of the solution is directly proportional to the concentration of the solution and to the intensity of the light. You write this statement and then write the mathematical form. So first, let the intensity of light equal to I, and concentration of solution equal to C. Then, and thickness equal to, mathematical forms of Beer-Lambert's law is minus decrease in intensity minus di, decrease in intensity with thickness divided by with thickness, that means minus di by dx is directly proportional to the concentration of the solution, that is C, and intensity of the light, that is I. That is minus di by dx equal to is proportional to Ci. Okay, or minus di by dx equal to epsilon Ci. So epsilon is proportionality constant, and this is known as molar absorption coefficient. Molar absorption coefficient. This is the mathematical form of UV visible spectroscopy. This is the mathematical forms of Beer-Lambert's law. And if we arrange them and integrated, then the simple form is come. Now, or minus di by I is equal to epsilon C dx. Okay, and integration di by I equal to minus epsilon dx. Okay, if we limit this integration I0 to I and dx is 0 to x, then we found ln I0 equal ln I by I0 equals to minus epsilon Cx, or I by I0 is equal to minus e to the power minus epsilon Cx, or I is equal to I0 e to the power minus epsilon Cx. Here I0 is the initial intensity of the light, and I is equal to, after absorbing some radiation, that is the final intensity of the light. Okay, this is the mathematical form of Beer-Lambert's. This is the mathematical form of Beer-Lambert's law. If we arrange them ln into log, that is another mathematical form. From here, ln I by I0 equal to minus epsilon Cx, or ln to log I by I0 is log I by I0 equal to minus epsilon Cx divided by 2.303. This is also an expression, and here one term comes, that is absorbance. absorbance. It is represented by A, and A is equal to log I0 by I. Okay, this is the total form of Beer-Lambert's law. If we plot this Lambert-Beer's law, then the plot is so the all expression is log I0 divided by I equal to epsilon Cx. This is one. And absorbance. This is the absorbance, or A is equal to epsilon Cx. This is one expression. And another I divided by I0 is called transmittance, that is T. So log I by I0 is equal to log T. Log I0 by I by I0 equal to log T, and this is log I0 minus A equal to log T. This is the total experiment. This is the total mathematical form. And if we plot percentage of transmittance versus concentration and percentage of transmittance, then we find a exponential curve. And if we plot absorbance versus concentration, then we found a straight line. Okay, this is the total Lambert-Beer's law, and this is the plot. These plots are also very, very important. And now we will discuss the main theme of UV visible spectroscopy, that is the theory of UV visible spectroscopy. So what happened in UV visible spectroscopy or electronic spectroscopy? Here the matter at first absorb light from the electromagnetic spectrum, and when the frequency of this light is matched with the difference of two electronic levels, the frequency of two electronic levels, then the electron jump from ground state to higher energy state. This is the main theory of the electronic spectroscopy. That is, in molecules there are so many energy level. That is ground level, that is ground state. Here the electrons stay more and more, and this is the more stable energy level. Then it is the first excited state, that is electronic excited state, and between them there are so many energy level: electronic vibrational level, rotational level, and etc. In these two electronic levels, there are some vibrational level and some rotational level. So the energy gap between two electronic level is more than the vibrational and rotational level. That's why when UV visible light absorb a matter, that is the energy of UV visible spectroscopy is high. So the electron jump from one energy level to higher electronic level, and if the energy is so small, that is IR or microwave, when the energy is quite small, that is for IR region and for microwave, then the electronic spectroscopy does not show, then only show rotational or vibrational spectroscopy. Okay, so when molecule accept energy from electromagnetic spectrum which match the frequency with the frequency of the two energy level, then the electron jump from one energy level to higher energy level. If the energy is quite small, that is energy match with the frequency with this, that is here, then the electronic excitation does not occur. Okay, so only when the electron is the frequency is completely matched, then the electronic jump is occur. Okay, so when the electrons are jumped from one energy level to higher energy level, with the electronic transition, with this electronic transition, there are some rotational transition or vibrational transition, because in the gap there are so many vibrational or rotational level. That's why when electronic transition occur, there also occur electronic vibrational transition and rotational transition. Okay. Here one question comes, that is why electronic spectroscopy gives broadband, not peak. That is UV spectroscopy or electron spectroscopy plot is this type, not this type, because with electronic transition there are some rotational level or vibrational level. So with electronic transition there also occur vibrational transition and rotational transition. That's why UV spectroscopy or electroscopy does not give a peak, it gives a broadband. Okay, this is the very important question. Now we discuss which type of electrons present in molecules or which type of electronic transition occurred. So at first we know which type of electron present in molecules. First we know there are pi electrons. Everybody knows there are pi electrons and sigma electrons, pi electrons, sigma electrons and non-bonding electrons. Three types of electrons in molecules. Not every molecules, but pi electrons present, sigma electrons present and non-bonding electron also present. So which type of transition occurred? So the more stable electron is more stable bond. Which bond is more stable? Sigma bond, pi bond or non-bonding? That is sigma bond is more stable. So the energy of sigma bond by sigma electron is less, that is more stable. Then the pi electrons then the non-bonding electrons, and they are also present. This is the bonding electron, so they are also present non-bonding, anti-bonding orbital. This is the bonding orbital, so also present anti-bonding orbital, that is pi star and sigma star. So if we consider this is the electrons present in molecule in this type, so transition occurred sigma to sigma star, sigma to pi star, pi to sigma star, pi to pi star, n to pi star, and n to sigma star. Total 6 type of transitions is occurred, but actually 6 type of transition does not occur because there are some selection rule. We read it in previous lecture. There are some selection rule. So the selection rule is what? The symmetry selection rule, spin selection rule, and angular momentum selection rule. So which transition are allowed and which transition are not allowed, it is explained by selection rule. Here we know the sigma to sigma star. We write the allowed transition. Allowed, which are allowed transition? Sigma to sigma star. Here the same symmetry, sigma sigma. It is same symmetry. It is sigma, it is also sigma. It is sigma star because it anti-bonding. So this is the symmetry allowed, spin also allowed. And sigma to pi star transition are not allowed because it is symmetry forbidden. Symmetry rule, it does not follow the symmetry rules because the symmetry of sigma orbital and symmetry of pi orbital is different. So sigma to pi star transition does not occur. It is forbidden transition. And pi to sigma star also does not occur. Pi to pi star, it occurred. It is allowed transition. N to pi star and N to sigma star. These 4 type of transition are occurred, but all 4 transition are not allowed. These 4 transition are occurred. This is allowed transition. This is allowed transition. This is allowed transition. But this is not allowed transition. This is forbidden transition. But this transition also occurred in practice or in reality. These transitions are discussed or explained in the next class.